Hello everyone, this is Abhijit Mahapatra and welcome to my channel. And as you know, this is the second part of our analysis, where we analyze the renewable energy and weather condition of a country. And before going to the second part, let's summarize the gist of the first part. So first we have just the basic things like we import the library, then they load the data set, and do the statistical things like the description, other things, and the and what we have analyzed in the first part is the what are the factors which is affecting the energy delta. As we already know, energy delta is not that energy we have used in our house or the energy that the population of that geography used. This is the energy delta, means the difference between the energy uses between two consecutive terms. Okay, like energy uses by is in this minus this is equal to that. So here zero means there is no difference of energy uses. Like here, if here is 10 watt of energy, then here if there is 10 watt hour of energy, then the difference between each 10 minus 10 is 0 watt hour. As you understand that, then we go for that which factors which is means affected our energy delta. So here we have found, we have done multiple of things and generating different graphs like histograms, or here like the relation between the time and energy delta. Here we found a most interesting thing, or the most important thing, the relation between the temperature, or the one of the factor is the temperature. So here we found the relation between the temperature and the energy delta. So before going to the analysis of the further analysis, I just want to, as I have promised that I will taught you, or I have explained what how I written the code. So here we begin, like in this code, this is a simple subplots. Here I have two axes, like here axis one having one again two plots. Okay, so in the first axis this is zero, like we know that in Python the first one is zero, indexing number zero. So here is the zero. So what we have done, the time. Here this is time. In the x-axis we have the time, and the y-axis this is the temperature. Okay, here you can see the time and temperature, and this means this is the gradually change of the temperature with respect to the time. So in the second part we have, you can see we use a line plot. In the both cases we use line plot, and in the x-axis we have the time, and the y-axis we have the energy delta. So here we can see, sorry for that, here you can see there is a significant, what you call the, it's like a mirror image, not like exactly a mirror image, but the mirror reflect, you can see the change of the heat with respect to time have the same reflection, the change of energy delta with respect to time. You can see that, although it is not exactly mirror image, but we can analyze that they have directly, the temperature change in the temperature have the directly affect the energy delta. So this is the one of the most significant analysis, or the significant information which we have in that analysis. So next we generate different graphs. Like here we generate the consumption graph, which means the energy consumed means, sorry, energy consumption over the year. Like we have the starting year is 2017 and ending year is 2022. So you can see it's like a Gaussian curve, like like it's like a sinusoidal curve, like this one. So to justify that, bring more information about that, so we develop more curves, like it's the mean energy delta with each hour. So you can see that this curve also signify that, like a in some time where there is no change in the energy consumption, while there is a significant change in energy consumption, and we can find the peak hour of a day. So this the peak hour is last between the, like you can say that that 9 a.m. to mostly 3 p.m. something. So these are the peak hour. So we can, and now we found the month where we use the energy most. So this is the fourth, the energy increase, significantly increase from the second month. As we know that after February the temperature of the environment is increases. So it's like as we on the basis of the data we can assume this country is lies in the northern hemisphere. So here you can see as the temperature increases, the energy delta increases. Here the 6 months, which is like January, February, March, April, May, and June. This is the May or June. This is the June month of June, which is the highest. Like we know, in June the temperature is mostly high. So here is the time: the May, June, July, August, September. So this time we need more energy. So just remember this curve, like the energy increases from 4 to 8 months, and here is the time, or the hour of the day, like in the 9 a.m. to mostly 3 p.m. we need more energy. Okay, so here the average temperature. Now we can see that here you also see that here the temperature of the day increases like in the 9 or 8 p.m. Then it increases up to, it's maybe like it's 1 a.m. or 2 1 p.m. or 2 p.m. Now decreases. So this graph mostly reflected in this graph. Okay, now our analysis is more we have more proof to our analysis. So we have done this. Now we are going to our second part. Okay, we have our problems here. Like in this time period, like in the if you got it in the one in a day, we have the peak hour. So here in this time period we need more energy, and in a year these are the months where we need more energy. So these are the problems. Let's find out the solutions. Like if we want to give a solution to a country, then we need to provide an alternative energy source. So what are the energy source based on our data? We have three type of energy source. One is solar energy. As you know how solar energy is generated, like using PV cells, like photovoltaic cells. Hydro energy is generated in a dam or using a turbine, water turbines, and wind energy like using a windmill. So we need to find out which one is the best suited for a country. As we know that although wind is present everywhere, solar energy is present everywhere, and hydro, like we have water, except in the desert we have water. But we need to find a feasible solution, not like which is feasible in the perspective of the economical and technological. So now we dig deeper and go to the solar energy, which is the first we will analyze first. So for the solar energy, we need the basic source is the sun. But what is directly influence the solar energy? It's not the temperature of the day. Like if we have temperature 50 degrees Celsius, then we have more solar energy. No, this is not correct. Like we need radiation, the solar radiation, which is here in the in this data set we have. Then you could say in the data set which one was this solar radiation. So this is the solar radiation. Then how do we know what is the GHI? We also mentioned here what is the GHI. Okay. Now GHI means global horizontal irradiation. Here although I written here. Okay, if you don't know, then we can go, and this is the global horizontal irradiation. You can find GHI here. And now, okay, sorry, global horizontal irradiation. Okay, then what is the global horizontal irradiation? It is the total solar radiation incident on a horizontal surface. uh, so it's like the total energy or the radiation of the sun is incident in the surface. And in this case, the surface is the geographical location of that area which we analyze. So this is our prime factor. So now we will find the how much is the global horizontal irradiation, and we will analyze the data furthermore. So let's begin, and just give a minute. Here we go. Now, here we will analyze the solar GHI, the global horizontal irradiation. So we want to know, we want to plot it. We will plot a graph which having the hour or the time of the day and the GHI, the maximum GHI. Here we will, if you want to summarize the graph or summarize the code, then you know here we plot the data where data dot unique. You want to you want if you will ask why we take unique. If you look in this data set, if we just give me a minute, just add a cell here and data here. If you analyze that, if you go there and if you see here hour, you have multiple like 0, 0, 0, 0, 1, 6, 16, 17. It will go up to 24. Okay. If you will analyze, if you don't summarize it, then it will give you it won't give you a best result. So what this will give you, it will give you the unique value of the column hour. What will be the our unique value? It's 1 to 24. And now the second part of obviously we need two data to plot a graph. The second part is data group by hour, means we will group by the entire data set in the column on the basis of hour. Then we will find the maximum of what? Maximum of GHI. Then we will find the maximum GHI for each hour in the data set. Okay, here we go. So here we will have the maximum GHI. So maximum GHI falls between 9 to 15. If you will wonder, this is the same graph where this graph is exactly matches the graph where we have the peak hour. You will just see the beauty of the analysis. Here you will see the mean energy delta for each hour. Here we have, means this is the peak hour where we need more energy, and this is the exactly the peak hour when we have the maximum GHI. So here we can use the solar energy to generate the electricity that needed that hour. Okay, but is that the final analysis? No. There is multiple factors which affect the GHI. Okay, we'll analyze it further and we'll discuss why and which factors are affecting the GHI. Now we will found the minimum of the in which time the minimum of GHI. Just give us just take a moment and find think in which moment in which time we will have a minimum GHI. The minimum GHI will fall where there is no what, there is, here you can see this is the minimum GHI. Minimum GHI will fall there is when there is no sun. Obviously, if there is no sun, then when how will be there is a global horizontal radiation, or how will be sun radiation is there. So these are the time where we don't have the GHI. You can find out also in this graph also. Okay. Okay. If you wonder why there is a GHI here and there is a GHI here, we know that the what do what the when the sun rising time is a variable time. It's not like every day in 6 a.m. we have the sunrise and every day in the 6 p.m. we have the sunset. No, it's depend of the day or depend of the month. So here is the time, like there is no GHI. Means the sunrise is after 6, you can see, and the sunset is mostly after 2 a.m. Although this it's like odd, but what is the graph? What is the data? And we have the graph. The graph will say what the data contains. Okay. Now we will plot the like average, which is the required one. Okay, we don't need a maximum. We cannot install a solar power plant based upon the maximum of GHI when we have 1 day or 2 day. We need a mean. Means in this time or in this time period we have also we have a constant GHI. So here also that same graph is generated like maximum in the 10 to like 12 like the same the mean the distribution of the energy delta over the hour, same as this graph. So it's evident. It's like we can say we can have an opinion, just opinion, not a fact. We can have an opinion that the solar energy is a good option for the solar power plant is a good option for the compensate the energy requirement of the country. But we will find, like we also know that there is a multiple factors affecting the solar energy production. Like if there is cloud is there, if snow is there, and then it will decrease the solar energy. How? If cloud is there, means the GHI will be lower, or the sun ray will not come easily, but the intensity of that GHI will be low. If there is snow, then snow will cover your solar panels, and if the solar panel is covered, then your energy generation capacity or the energy generation is fall. So we need to find out the
the effect of the cloud or in effect of, and effect of the snow. If okay, if there is no there is no or there is a minimal effect of the cloud or snow on the solar energy production, then so we can discuss we can say that the solar energy may be a good option. So before that we will find out what is the what is the result. So here we will same we unique the data so you will find the unique value of the hour and group by the cloud. The monthly cloud log. We have a column here which containing this data. Now here we can find the average cloud coverage for each hour. Here, so here we can see there is a cloud coverage is increases from the 7 to and decreases 150. In this primary loop, we can say that when there is a maximum need of energy and although we have a GHI is more although the 9 a.m. to 12 p.m. the sun is over your head and GHI will be more. But if in that the same time we have the cloud in the sky, then there is a negative effect in our solar energy production. But can we just say that fact from that one graph? Can we say no? So we need to dig more. Okay, let's go for the month. Month is also important because day or the hour is just we cannot derive more of thing from the hour. So we need to dig more. So we will go for the month. The average of GHI for each month. Okay, here we'll find out. Okay, here we can see that the 4 to 10. This is also the exactly same graph, the average of the consumption rate, the average of monthly energy delta for the month, the same type of graph we have here, and same type of graph is there for the average of GHI for the month. So this okay. Problem is there that we have multiple graph and we have to go ups and down to find out this. So we'll go and we'll see how we can have multiple graphs in a single. Although we have see the subplots and we'll use much more from the much more here. But now we'll see the minimum. Okay, we'll find out these graphs. And here we will have the maximum GHI for each month. Here we have the average cloud coverage for each month. Uh, See that when we will use this single graph, there is a problem like okay, if we need to compare this graph to average cloud coverage to the average GHI, we have to move like that, and we cannot have a single answer like oh, because we cannot see the both graph at once, so we need to see them at one point. So here we have the like the here we have the average energy delta for each hour and we have the average GHI for each hour. So we have two graph in one plot. Here we can see and you can see here. Here the average energy delta means these are the time where we need more energy and here these are the time we have more GHI means more radiation. So you can see this graph fit exactly like not 100% but 90 more than 90% is fits the peak, the starting of the peak, at the ending of the peak, everything is same. So in this graph, we can assume that okay, this is a good action. Now we'll go for the second one. Here we'll see that average energy data for each month and average GHI for each month. Means the time where the energy is required is more is the time where the GHI is more. This is the question we have arise if we need more energy in the November and if we have more GHI in the August, then there is no use. Okay, we cannot store the energy in the battery form, and this is not the feasible answer. So, if we have the same energy requirement, if we have the same GHI where we need more energy, if we have the GHI having more GHI and need more energy in the same month, then this is a more feasible answer. So, let's find out. Here we have look, look how beautiful it is. Same here you can see the energy requirement is increases from the second month and it will like stabilizes for the 4 to 6 month and it slightly decreases and decreases finally from the in the 10th month. If you will analyze the second graph where you can have the GHI over the time, over the month. We have the it increases from the second month, go to the maximum in the 6 month end, and it will decreases after the 8 month here. Also, it decreases after the 8 month, and the graph is more exactly same. Now we need to find the environment effect. We will now engage the environment effect. So now we'll bring back snow. As we already know, if there is snow, where the peak of when there is more GHI, or and if there is okay, firstly, if we need more energy in a particular time, here we have more GHI at the same time. If we have more snow at the same time, then our solar panels will be covered with the snow, and our energy production rate will be decreases, maybe nullified or maybe zero. So this is the most important factor. So we don't want snow at that time. This is the factor. We don't want snow at the time where the energy requirement is more and we have sufficient GHI. Let's see what the graph told us. Okay, here we have hourly plot. Okay, hourly plot for the snow, hourly plot for the GHI, and hourly plot for the same plot for the energy delta. What we'll see here. Okay, if we analyze that the same hour when we have the snow like that, and we have exactly same hour, the not exactly, but although the snow is from the 5 to 10 and we have the requirement 5 to 15, but is that feasible solution for if we want to ask from only on this graph? If you will ask me, then I will say not more that. So for a confident answer, we'll find out is there any snow in the month where we require more energy and having more GHI. If there is this is the case, then the solar energy is not a good option. Means if we need more energy in the duration of the 2 to 8 means like 4 to 8 month, month of the March to August or something like that, and if we have more GHI in that the same time, the more energy requirement at the same time. If there is more snow at that same time, then the solar energy is not a viable option in the exact same month. Okay, if that is the case here, if the answer is no, then it's a good news for us. Then we will qualify for the first environment effect. Now we can see. Although we have the snow for this hour, if we find out the hour, but here you can see this is the energy delta versus the graph versus the month. We have more energy requirement from the fourth month to the mostly ninth month something, and we have the same graph for the GHI. We have more GHI from the fourth month to the eighth month, here the eighth month, and you can see there is no snow. It means hardly any snow from the in the 4 to maybe 4.5 there is no, although very little, a bit little snow, but you can see that this 4 to 10th month there is no snow, means there is no effect of the snow in this month. So it's a good sign for our solar energy production. Okay, yeah, okay. Is this is only the snow is a effect for the solar energy production? No, we have the cloud. If there is a black cloud in the sky or the cloud in the sky, then solar energy will production will be affected. Okay, we'll see the same thing here. We'll see the hourly cloud data with the GHI and the energy delta. It is the same. Here we go. Okay, if you will see that the same condition here, as you know that the hourly graph, it is the cloud is there. Like we have the snow is there in the first part in the hourly graph. Okay, we will go for the second part, the monthly graph. If there is any cloud where we need more energy and we have the more GHI. Let's find out. Okay. Although we cannot say there is no cloud. Although if there is some cloud, also it is not possible that there is no cloud in the sky. But you can see that the effect of the cloud is very minimal in those period of time where we need more energy and we have the more GHI. GHI means global horizontal irradiation. Please remember that. So here the energy requirement is continuously rising, and this DHI also is continuously rising. And this here you can see the cloud coverage is continuously for which is the most important thing for us. Now we are qualified the solar energy production production is qualified for the is qualified for this snow effect, and the here we also qualify for the cloud effect. There is no cloud in that. Also there is some cloud, but the effect will be minimal. Okay, now here from the analysis we can say that yes, solar energy is is the best one of the best option for the renewable energy production, because it has this, when we need more energy, the GHI is more, the snow coverage is very less or is null, the snowfall is very less, and this cloud coverage is very low. So these all are the good sign for the production of the solar energy. Now move for the hydroelectricity. And for the hydroelectricity, we have two options. Either we have a glacier in the top where we have a continuous river and we can have a dam and we can generate electricity throughout the year. Either it's we need rain. We have rain, then we have a flow of river, then we stop it by a dam using a turbine to turn, then using a generator to generate electricity. Okay. So we need, because we don't have a glacier data set here, so we will rely on the rainfall. If the rainfall is gradually increasing or rainfall is stagnant, these are the best chance. Now let's see what is the behavior of rain here. So we'll go there and run the code. Here we'll use the same thing, but it's not feasible, it's not good or not a good option for finding the hourly solution. How much rain is falling in each hour? There is no meaning of that. So we need the average rainfall for that area for a year by year trend. Now we'll go for the year by year trend. So we have like 720 to like 4 to 5 years as well. So we have that unit data, then we'll group by it and sum. Here we're going to use average or the total rainfall. Okay, the total rainfall for a year. So now we'll go for that and here. So we have okay, there is a mistake here. Now we have the total. Okay, I could sum. We summarize. Would sum the rainfall for each year. Like in 2017, from the January to December, we will sum every drop of the rain, and for this we will use the same thing, or the group by statement will use the same thing for the every year. Now here we have our data graph. Okay, you can see. Okay, like that. The rainfall is gradually decreasing. So is that a good investment to design, construct a dam? Like dam is a multi-billion dollar, is a billion dollar project, $1 million project. If we have a dam and after that we can see there is scarcity of rain, then it's a loss of money, loss of effort, and loss of capital. So I don't think that hydroelectricity is a good option for that area. It's uh, it's my opinion based on that graph. Because the rainfall is gradually decreasing like 3,500 m this here, and we have like it's going steeply downward. So I don't think rain is a good option. Now we'll go for out the wind energy. Okay. Here we'll find the wind energy in the hourly basis. So here will the same thing, like we'll find a relation between the energy requirement in hourly basis and energy requirement and the wind energy, the speed of the wind each hour. Here we can see we can find out that okay, there is a wind. There is wind where we need more energy. Means if you can typically convert it to the energy, then okay, we can generate energy from that wind in this time of period. Okay, but it's hourly. Always remember that hourly cannot give you a sufficient answer. We need a broad perspective. So month is a good answer. We can find out this monthly season. Okay, we can find out the either if the month where we need more energy. Either the speed of the wind is high there, there is a wind speed is there or not. So we'll go for the graph for the month. Okay. I already explained how I run the code. Here the figure size. Here I use two graph with axis 0, axis 1, axis 0 the set title. Here the figure title, and we use line plot here. Okay. Here we can see when we need more energy, the wind energy, the speed of the wind gradually decreases. Then when we need more energy, then we have a wind energy there. But if the wind energy is sufficient to generate if the wind energy is sufficient to generate electricity, you cannot generate electricity with a very small wind speed. So it is found, it's generally accepted that the average wind speed, if the area have an average wind speed over the year is more than 5 meters per second,
it's feasible to have a turbine like large turbines if the wind speed is below 5, then it's not economical to have a windmill over there. So we'll find out the average wind speed over the year here. We can go and run the code and we have our answer. No, we have we don't have the average wind speed which is more than 5. We don't have an average wind speed which is more than 4.5 also. So this is so wind energy is not a viable option here. Now we'll go to our conclusion. Before that, we'll find some more beautiful plots here. Because pair plot will take some time because we have hundred thousands of data set here with multiple columns. Although the pair plot is not won't give much more information here because it will be very small. Small plots will be there. It's for just for the visual. I will show how a pair plot look like and how a heat map look like. Here we map we will find out the correlations. Okay. The time when okay, we'll just have to wait for some time. So we'll basically go for our conclusion and hope the graph will be load in that same time. So what we are concluded, solar energy is the best option for the geographical area for this geographical area where they can fulfill their energy need as there is hardly any snowfall or cloud coverage when the energy delta is in peak. As we already discussed here, look, when the energy delta is in peak, the cloud coverage is very low. When the energy delta is peak and we have GHI is more and there is just very minimal snow. So this is a very good option. Now we'll go for the second analysis, second conclusion. That is either the same duration the GH in that same in that same duration the GHI is more. Okay, the third is it is noticed that there is a continuous decrease in rainfall, so it is not viable to rely on it as a huge capital investment is required for a construction of the hydropower project. As we already discussed here, we can see the rainfall is gradually decreases over the year. So there is no, it's not feasible to have a we'll plan to construct a dam on the basis we'll construct a dam on the basis of what? We don't have a data for the glacier. We don't know either is this country have any mountain or something. So we have to rely on just on the rainfall. So if you see that the rainfall is gradually decreasing, then we cannot predict. We cannot say that okay, let's go and build a dam over there and produce energy. No, I don't think this is a viable option from my perspective. And now we'll go for the second analysis, that is in this case of solar energy, GHI is maximum in the although we discuss here. And for the okay, I just missed one thing. This is wind energy. So wind speed in this area is very okay. Okay, we will not generalize the statement like the very low or something. We will just state the fact is not suitable for energy production. Why? Because the average wind speed is less than sorry 5 meters per second. Okay, it's not the 5 kilometer per second, meter per second. Okay, these are so we know that the solar energy is based because of the factorial analysis. Then why the hydro energy is not good for us, and why the wind energy is not good. Wind energy is not a good. It's not a good for us. This is right. It's like not a viable option for us. Okay, and what we have discussed more is that
the energy delta is directly dependent upon heat or the temperature of the environment. Like if we have a more temperature in the environment, then we'll use more electric equipment like fan, AC, air conditioner, HVAC system, more things. So it's a direct, it will directly affect. And these are the things we have discussed here, how we generate single graphs, how we generate multiple graphs uh, in a one query or the on a one what to say one code. We can we have three graphs in a code. You can draw multiple graphs in a code. It's just play with the codes. I'll provide the link of the codes which you can find in the Kaggle or the GitHub. Okay, I'll provide my LinkedIn link. Please contact me here and go to the Kaggle and GitHub. If you like that, just give a star over there. And every if you have any doubt or suggestion about the video, please comment there, and I will give you the answer, or I will give you the uh, possible answer what I have. Okay, just please subscribe my channel, and if you like, then please share it to your friends. Will provide we will publish more video using using Python, and I will provide more video if, how to use how to write Korean and SQL uh, like that. Okay, now we will see our pair plot here. Here we have our paper. Like I said, there are multiple columns are there, so the paper is not visible. If you just go and zoom here you can see the same thing. The energy delta we have GHI. The same thing we have already discussed. Okay, now you can zoom wherever you want. You can see that. Now this is our heat map. You can see the year is correlated perfectly correlated with the year here. If there is a perfect correlation, then this is the white one. The darker you can see here is the mark out the level of the correlation, and here are the columns. Okay. This is the end of the video. Thank you for watching. Please subscribe my channel and share it if you feel it's worth. And I will provide the link of the Kaggle and social media accounts if you just connect me in LinkedIn. And if you want to find the code, you can find it in the Kaggle and the GitHub. If you like the code, just give a star there. And thank you. Have a good day.